I have no idea. I changed the order of a few things and then uploaded it to Momentum, and the order's not changed. I don't know why that is, but let me come back to that slide in just a minute. What I decided that I'd rather do first is this screen on a formal hypothesis test. Based on the words that I just said, we want to say there is enough evidence to support the claim of a linear relationship, or there's not enough evidence. Those words should have made you think, ooh, that sounds like a hypothesis test. The notation, N, is still number of pairs of sample data. R is our linear correlation coefficient for the sample data. And then there's something else that's I'm going to mention now, but later it's not going to be important. This looks like a P, kind of italicized P maybe, but it's actually the Greek letter rho. And rho is the linear correlation coefficient for the population. We're trying to say, yes, it looks like my sample has a strong linear relationship, so I'm going to make the prediction that my population also would have a strong linear relationship. The null hypothesis would be that rho is 0. If the population correlation coefficient is 0, well, 0 is a correlation coefficient, means there is no linear correlation. If that's our null hypothesis, then our alternate hypothesis would be that rho does not equal 0. That's like R, but for the population instead of the sample. So if it doesn't equal 0, then there is a linear correlation. If we and this not equal to in the alternate hypothesis is why we clicked the not equal to on the calculator a few minutes ago. We're always going to be doing a two-tailed test for linear correlation, so you can just leave that not equal to highlighted. The calculator screen gave us R. It will also give us p-values, which some problems in the homework ask for a p-value. We're not really going to use them, but if it asks you, then look at your calculator and type in the p-value. In all of our other hypothesis tests, we use the p-value and the significance level, p and alpha. If p was less than alpha, what do we do with the null hypothesis? P is less than, p is low. We rejected the null hypothesis, and if p was high, we failed to reject the null hypothesis. Here, instead of using p-values, we're going to use critical values. And this is the only time that you'll need any of the tables in the back of the book. In the homework problems where it asks for critical values, there'll be a little icon you can click on, and that table will pop up so that you can see your critical values. We're going to compare our critical value, our test statistic R. We're going to compare R to the critical values we get from the table, and I'll show you the table in just a second. If the absolute value of R is bigger than the critical value, then we'll say there is a linear correlation. If the absolute value of R is less than the critical value, then we'll say there is no linear correlation. Now, there's something easier for me to remember than that absolute value of R, but that's the way the multiple choices are listed in the answers in the homework, so that's why I'm showing you absolute value of R. But it's easier for me to think about it like this. When we were trying to determine if z-scores were usual or unusual, what were our cutoff z-scores? -2 and +2? Anything inside that was or was not unusual? Was not unusual. Anything outside that was unusual. Similarly, for critical values, if we put our critical values on a number line and then our R value falls between those critical values, then there is no linear relationship. your R is close to 0, and R close to 0 means no correlation. If our R values are outside those critical values, then they're closer to +1 or -1, and there is a correlation, a linear correlation. So let's talk about how to get these critical values off of the table A5, and then we'll be ready to conduct that hypothesis test. The critical values are the values that separate the likely from the unlikely. That's what critical values have always been. Our Z sub alpha or our Z sub alpha over 2, those critical values have separated what's likely to happen by chance from what's not likely to happen by chance. So those critical values for the correlation coefficient are the same thing. Anything outside them indicates there is a linear correlation. Anything inside them means there is no linear correlation. The only two things you have to know to use this table are your number of ordered pairs and your significance level. We're only going to use two significance levels, 0.05 and 0.01. So on that pizza Subway problem, how many ordered pairs did we have? We had 6 ordered pairs. And so for a significance level of 0.05, if I said find the critical values for that problem, you would read down to 6 ordered pairs, critical value or significance level 0.05, the critical value would be positive 0.81. But just like Z-scores, a Z of +2 and a Z of -2, both of them are the same distance from the mean. Both of them have the same area to either end. Here, this critical value of positive 0.811, there's also a critical value of negative 0.811. I think in the homework, there's a plus or minus already typed for you, and then there's a box for you to type in that critical value. If you read it off the table and put it in the box, then you're saying the two critical values are positive 0.811 and negative 0.811. So I understand how to use that table. I understand that if R ends up between those two, the positive and negative critical values, there is no linear correlation. If it ends up outside, then there is a linear correlation. So I think we're not going to set up all the steps for a formal hypothesis test. We're just going to use the value of R that we found on our calculator a minute ago. The R is 0.988. And we're going to use the critical value for 6 ordered pairs and a significance level of 0.05. That was the value we just got off the table, 0.811. And we're going to compare the absolute value of our R to the critical value we got off the table. On this example, is the absolute value of 0.988 greater than the critical value or less than the critical value? It's greater than, positive 0.988 is greater than 0.811. And what does that mean? There is or is not enough evidence to say there's a linear relationship. If it's outside, close to +1 or -1, then there is a linear relationship. Now, I've talked about this for 35 minutes already, but here's how quick the homework problems are going to be for 10.2. You just put your ordered pairs in list 1, list 2. Use linear regression t-test to get the value of R. Use table A5 to get your critical value, and then compare them. If the absolute value of R is bigger than that critical value, there is a linear correlation. Otherwise, there is no linear correlation.